This video is to provide a few more examples on solving rational equations. So if you watched my first video, you would have seen, the steps involved in solving a rational equation. Here we're just going to do a few more examples and then talk about some special cases. So if I said to solve 3/4 minus 2 over x equals 11/5. So if you have an equation with fractions, the first thing you want to find is the LCD for all the fractions that appear. And, when we're talking about the LCD, we're saying the lowest common denominator, the least common denominator. So we're looking at the denominators, 4, x, and 5. For 4 and 5, the smallest number they both go into evenly. The smallest number they're both factors of is 20. And then you have a factor of x here, so you need a factor of x, so 20x. And then remember what you do with it. You want to multiply 20x to every single term. So we would take 20x times the 3/4, 20x times the 2 over x, and 20x times the 11/5. And when we do this, remember the goal is to clear fractions. So when we multiply each term by the LCD, the idea is that it'll divide nicely with the denominator. So 20x, how does it cancel with the 4? Well, the 20 cancels the 4 to a 5, but the x stays, so we end up with 5x times 3, so then you multiply those together to get 15x. Minus here, we have 20x, divided by the x. The x's are going to cancel out, so I'm left with 2 times 20, so it's going to be minus 40. And it's equal to, here we have 11/5 times 20x, so what cancels here? Well, the 20 divides by the 5 evenly to give me a 4. The x stays, so we have 4x times 11, which makes that 44x. And now your fractions are gone, right? They're cleared out. That's why we multiply by the LCD. The goal was to clear fractions. Once we've done that, we're going to go through and solve as you normally would, getting the variables to one side and the constants to the other. So I'm going to subtract 15x from each side. I end up with negative 40, don't lose that negative sign, equals 44. 44x minus 15x gives us a 29x. And then to solve for x, you want to divide by the coefficient. So we divide by 29 to each side. 29's cancel here. We end up with x equals negative 40 over 29, which doesn't reduce. You can leave it as negative 40 over 29. That's the exact answer. I leave it like that. And you should check to see if this variable would make any of your denominators in the original 0, but this x here would not come out to 0, so we're okay. Let's take a look at another one. If I said to solve two over x squared minus 1 minus 1 over x minus 1 equals 1/2. So we have an equation, right? That's the equal sign shows us. It has fractions, and you have an equation with fractions. First thing you want to do is try to find the LCD. Now, to find the LCD for these rational terms we have in here, you want to make sure that you factor the denominators completely. So the x squared minus 1, we should factor that, right? Don't lose that, it's important. So x squared minus 1, well, that's actually the difference of perfect squares as factors to x plus 1 times x minus 1. And so if I'm looking for the LCD here, or how the LCD works, you want every factor that appears in any of the fractions, and then you want the highest power of that factor. So looking at this, we've got a factor of 2. These don't have any other coefficients, so we definitely need 2. Here we have a factor of x minus 1. Here we also have x minus 1. So that'll stay as a factor of x minus 1 to the first power, because remember you want the highest power that you see, and we see the highest power is the first power. And we also have a factor of x plus 1. So it's really going to be 2 times x minus 1 times x plus 1. And then you want to multiply that to every term. So what I'm really going to do is take this 2 times x minus 1 times x plus 1 and multiply it to each term in the equation. So we have 2 times x plus 1 times x minus 1. And again, the order here doesn't matter because multiplication is commutative. Times 2 over, maybe I'll write it how I wrote it in factor form. So x plus 1 times x minus 1 minus here, again we'll have 2 times x plus 1 times x minus 1 times the 1 over x minus 1, and this is equal to 2 times x plus 1 times x minus 1 times the 1/2. So I just took each term and I multiplied it by 2 times x plus 1 times x minus 1, my LCD. And then what you want to do is you want to use this to clear fractions just like we did before, right? So when you multiply by something, you have that same factor in the denominator, you're allowed to divide by it to cancel out. So here in this first fraction, the x plus 1s will cancel, and the factor of x minus 1 will cancel. So I'm left with just 2 times 2, which makes this just 4. Here I have minus, don't lose the minus sign. Here the 2 times x plus 1 times x minus 1 times the 1 over x minus 1. Well, the common factor that you can cancel off from the numerator and denominator is the x minus 1. So you're really left with minus 2 times x plus 1 times 1, which is negative 2 times x plus 1. Keep those parentheses there until you distribute in. And this is equal to, don't lose your equal sign here. The 2 will cancel with the 2 in the denominator, so I'm left with x plus 1 times x minus 1 times 1, which I can write as just x plus 1 times x minus 1. So now I'll distribute through. Notice our fractions are gone. That's good. If your fractions don't clear at this point, it means you didn't pick the correct least common denominator. You didn't pick a common denominator at all. So we're going to simplify this. So we end up with 4. We're distributing a negative 2 into here. So 4 minus 2x. Negative 2 times 1 makes us a negative 2. It's equal to, here, x plus 1 times x minus 1. You can FOIL this. You should know, though, that that came from our difference of squares. So that's, when you FOIL this, you should end up with x squared minus 1, or if you multiply that out. And the middle terms will cancel, in other words. And now remember what your goal is. If you have an equation here and it's a quadratic, or it's a power 2, or even higher, you want to get one side equal to 0 to try to solve this. So to solve this, I'm going to try to get this this left side to 0, and I'll get all the terms on the right. So to do that, I have 4 minus 2. Maybe I'll combine like terms here first. So I have 2 minus 2x equals x squared minus 1. And then to move everything to the left side, I'm going to subtract 2 from each side. And I'm going to add 2x. I'm going to do these in the same step. You could do these individually if you wanted to. So when I do this, I'm left with 0 on the left is equal to, I have x squared, and I'm going to write it in descending order. So plus 2x, and then minus 3. Now once you have a quadratic, you want to try to solve this by factoring. To solve this by factoring, you should be looking for a GCF. In this case, I don't have a greatest common factor other than 1. No GCF to factor out. I notice I have 3 terms. I don't see a value in front of my x squared, so right away I know I can make 2 sets of parentheses with x in the front of each of them. I want numbers that multiply to a negative 3 and add to a positive 2. And the factors of 3 are only 1 and 3, so there's only a couple ways to do this. To get to a negative 3, it's either negative 3 and positive 1 or positive 3 and negative 1, and we know it's positive 3 and negative 1 because I have to add to a positive 2. So you have x plus 3 times x minus 1 equals 0. And then remember how you solve. You set each of these factors equal to 0, right? So I set x plus 3 equal to 0. I set x minus 1 equal to 0. Solving this, you subtract 3 from each side. Get x equals negative 3. Here, add 1 to each side. I get x equals positive 1. So it looks like I have 2 answers here. You should be checking, though, make sure that in your original problem, neither of these makes a 0 denominator. Well, if I look up here, negative 3 squared, that'll be positive 9 minus 1. That won't be a 0. Negative 3 minus 1, that won't be a 0. So negative 3 is okay. 1, on the other hand, 1 squared minus 1, well, that would give me 0. Right away, you could reject 1 just based on that. Or here, 1 minus 1 is 0. As long as it happens in one spot, then you have to reject it. So make sure you show this. Don't just cross it off so I can't see it. So let's put a little x there. I'm saying reject. 1 is a solution. So my only solution is negative 3, so you'd write this as negative 3 in the set notation. If I didn't ask you for set notation, just writing x equals negative 3 is fine. But this is the solution. We rejected, all right, we rejected x equals 1 because it made one of the original fractions undefined. Actually, 2 of them, right? It made the 0 denominator in one of the fractions, or in this case, 2. Let's talk about what happens in this case. Alright, let's try solving this one here. So we would have 20 over 2x squared plus x minus 3 minus 3 over 2x plus 3 equals 4 over x minus 1. So you might want to pause it and try it on your own. We have an equation, it's a rational equation, it has fractions in it, so the first thing we want to do is try to find an LCD. Before we can find an LCD, we want to try to factor all the denominators completely. So the 2x squared plus x minus 3, the other two you don't have to worry about, they're already factored completely, but 2x squared plus x minus 3, you should look for a GCF. In this case we don't have one. You have three terms, you see a value in front of the x squared, so you can either use AC method or reverse FOIL trial and error. I'm going to do this by using the reverse FOIL trial and error, because 2 and 3 are easier numbers to work with. So 2x squared, I know I need 2x times x in the front. To get to a negative 3, I know I need to do 1 times 3, and one of them has to be positive, must be negative. Trying to figure out where those should go. Remember, you have to see how they add to the middle when you FOIL it. So, I'm going to do 2x, I'm going to put the plus 3 here and the minus 1 here. Now, these might tip you off as to what those might be, but it doesn't always have to be the case, so you should check it. You have 2x squared from the, the first. The outer, you do 2x times the negative 1 being negative 2x, but then you get a plus 3x from the inner, so plus 3x. And minus the 2x will give me the positive 1x. So that's how this factors 2x plus 3 times x minus 1. The LCD here, remember you need each factor appearing to be in your LCD, and you want the highest power of that factor. So I have a factor of 2x plus 3. I also have one here, but the highest power we see of it is just to the first power. I have a factor of x minus 1. I also have a factor of x minus 1 here. Again, highest power I see is the first power. So once you have that, now you're ready to multiply through that LCD to all the terms. Remember, that's what you do when you solve an equation. If this was an expression, you were just adding or subtracting. You can't just multiply all the terms. Because it's an equation, the equal sign is telling you multiply that to everything. So if I was to do that, I'd take 2x plus 3 times x minus 1 times 20 over, maybe I'll write it again in the factored form, so 2x plus 3 times x minus 1 minus 2x plus 3 times x minus 1 times 3 over 2x plus 3, and it's equal to 2x plus 3 times x minus 1 times 4 over x minus 1. And then you want to go through and cancel. Remember, that's why we're doing this. We're going to try to clear fractions. Well, in the first fraction, the factor of 2x plus 3 cancels with 2x plus 3. The factor of x minus 1 cancels with x minus 1. This is all just a 1 in front, so it's 1 times 20, which just gives you 20. Minus, don't lose your minus sign. Here, 2x plus 3's cancel, and you're left with x minus 1 times 3, which I'm going to write as 3 times x minus 1. It's just going to be easier to work with in that order. And it's equal to, here, the x minus 1's will cancel, and you have 4 times the 2x plus 3. And your fractions are gone. That's why we did this, to clear fractions. Once you've cleared fractions, now you solve as you normally would. So we want to distribute through this. So I have 20. We're distributing a negative 3. Make sure you take the negative with it. So this will be minus 3x. A negative times a negative makes that a positive 3. It's equal to, here, distributing the 4. 4 times the 2x gives me 8x. 4 times 3 gives me plus 12. And then I'm going to solve this, combining like terms and then simplifying. So 20 plus 3 is 23. The minus 3x will stay minus 3x equals 8x plus 12. Because we have linear terms of x, in other words, they're the first power, you want just to get all your x's together on one side, everything that doesn't have an x to the opposite side. So maybe I'll add 3x to each side here. So you get 23 equals, this is going to be 11x plus 12. And then I will subtract 12 from each side, so subtract 12 and subtract 12. I end up with, I'll write these cancel, so 11x is equal to 23 minus 12, which is 11, and then we divide by 11 to each side, so I get x equals 1. Now, remember, you want to check these. So x equals 1, you want to go back up to the original problem. Does 1 make any of these denominators 0 if I substitute it in? Well, right away you can see if you put 1 minus 1 here, right, in for x, that would make this 0 denominator. As soon as it doesn't work in one spot, you know that you can't use it. You can reject the answer. Also here, if you substituted in 1, either into the 2x squared plus x minus 3 or into the factors down here, you would have gotten a 0 denominator. So x equals 1, we have to reject that answer. So what happens? Well, then we don't have any answer. We don't have any answer, then we say there is no solution. And that's possible, right? That means there is no x value that would solve this equation to make it true. That's all that means when we get no solution. So the answer is no solution. You may also see this written as the empty set, so 2 curly braces with nothing in it. Or another way of writing that would be with the 0 with the line through it. That's the other way of writing the empty set. So these both mean the empty set, which really means there's no solution, right? There is no solution set that makes this true. The last part of this section, we're going to talk about cross multiplying, which you probably have heard of before, but maybe you don't understand when to use it. So just a quick note. You only cross multiply when trying to solve an equation that is a single fraction equal to a single fraction. So it's only one term on each side of the equal sign and they're both fractions. So you only cross multiply when you have a single fraction equal to a single fraction. So if I was to say I had a over b, just in general, is equal to some other fraction, c over d, what cross multiplying allows you to do is it says, okay, I can go down this cross and say, okay, I have a times d, and that's equal to going up the other cross, b times c. And the idea is that fractions are gone. So it's a shortcut way to clear fractions is really what you're looking at. So it's not a, cross multiply all the time. It's only when you have one fraction equal to one fraction. In the previous examples I've showed you, we had more than one fraction on each side, so you couldn't use cross multiplication. You also don't use it in any other way in math. It's always about an equation, so it has to be an equal sign in between two fractions. So, for example, if I said to solve x minus 3 over x plus 4 is equal to 2 over x minus 6. Now, you could solve this like we had before, finding an LCD and multiplying to each term. It actually works out the exact same way. But if you notice it's a fraction equal to a fraction, the easiest way to handle this is to cross multiply. So if I cross multiply, I can go down this cross and I can say I have x minus 3 times x minus 6. Make sure you put parentheses around those because the entire factor times the entire factor. Then you have to have an equal sign in between. Don't lose the equal sign. You still want it to be an equation. And then you go up the other cross. X plus 4 times 2, which I'll write as 2 times x plus 4. Again, make sure you have parentheses there because it's 2 times that entire factor. Once you have this, now we're going to multiply through. Notice our fractions are gone. Right? That's all we were aiming at, was to clear our fractions. So if I went through here and I foiled this, right, I'd have x times x gives me x squared. I would have x times a negative 6, which gives me negative 6x, and then I get a minus 3x from my inner, so negative 6x minus 3x is negative 9x. I did that kind of in my head. You should be able to do that at this point. Negative 3 times negative 6 is a positive 18. So we have x squared minus 9x plus 18 equals, on this side distributing the 2. 2 times x is 2x. 2 times 4 is a positive 8. Now we have a quadratic equation. The highest power there is 2. So to solve this, remember you want to get one side equal to 0. So I'm going to subtract 2x from each side here. I'm also going to subtract 8, so I'm going to get 0 on the right. So this leaves me with x squared minus 11x, right? Negative 9x minus 2x is minus 11x, plus 18 minus 8, which is a positive 10, equals, don't forget this is an equal sign, equals 0. Don't lose the other side of the equation, otherwise you don't have an equation anymore. And now I want to solve this. To solve this, we'll factor. There is no GCF here. You have three terms. You don't see a value in front of the x squared. So right away, two sets of parentheses to reverse FOIL this. We have x times x multiplies to a positive 10 and adds to a negative 11. Numbers that do that are a negative 10 times a negative 1. Solving this, you set each factor equal to 0 now, remember? So we have x minus 10 equals 0 and x minus 1 equals 0. I'll add 10 to each side here. I get x equals 10. Here I'll add 1 to each side. I get x equals 1. And so I have two solutions, 10 and 1. Make sure neither of those makes this denominator 0. Well, here 10 plus 4, that wouldn't be 0. 10 minus 6, so 10's good. 1 plus 4 doesn't make it 0. 1 minus 6 doesn't make it 0. So two answers, 10 and 1. You could write this in set notation as 10 and 1, or 1 and 10. Order doesn't matter inside of a set. But make sure you understand that the solution is two answers here. And that's okay. You have two answers that could make this true. Either x is 10 or x is 1. Now, we solved this by cross multiplying. But if you didn't know about cross multiplying, or you didn't feel comfortable doing that, if you found the LCD at the very beginning of this, the LCD would have been x plus 4 times x minus 6. And what you would have done is you would have said, okay, multiply that to each term, right? So you would have ended up with, just as an aside here, you would have had x plus 4 times x minus 6 times the x minus 3 over x plus 4, right? Multiplying to that side. And it would be equal to x plus 4 times x minus 6 times 2 over x minus 6 on the right side. And when you do that, what happens? Well, the x plus 4's would cancel here, and you'd get x minus 6 times x plus 3. Here on this side, the x minus 6 is canceled. You're left with 2 times x plus 4. And so you're in the exact same spot as we were right here. So you don't have to cross multiply. You could always just multiply by the LCD like we always have, and you'll get to the same place. Cross multiplying just gives you a quick way to solve if you have a fraction equal to a fraction, so you don't have to find the LCD. But it only works if it's a fraction equal to a fraction. So hopefully this video helped with the examples on solving rational equations. Remember, you're only allowed to multiply through by the LCD if you have an equation, if there's an equal sign. And that's what causes us to clear fractions. If you just had an adding or subtracting problem with rational expressions, you would have to rewrite using a common denominator and keep the denominator as the LCD. You wouldn't be able to just clear it right out. You need it there when you're simplifying. But if you're solving, like we're doing in this section, then you're allowed to clear fractions.